Hello everyone and welcome back to Diksha Karnataka YouTube channel, and today you are watching KPL number 13, Physics KPL number 13. So we have already completed 12 previous KPLs. Today is the 13th day. So today we are going to conduct KPL from including some chapters from your first PU, some chapters from your second PU. I hope you have answered those questions and you are ready for this week's KPL. So we are going to cover what are all the chapters. If you are still wondering, kinetic theory of gases, then thermodynamics and thermal properties of matter, and from your second PU we are also covering AC in today's KPL. Okay, so these are the most important chapters. So out of these chapters, AC is obviously the most important. Other chapters are from first PU. One questions every year comes from these three chapters, so they are also somewhat important. If you are wondering, if you are preparing to get 60 in your KPL, in your KCET exam, right? So without any delay, I will going to start this lecture. But before that, I have an announcement that you have to join our WhatsApp channel. The link is given in the description. A lot of things are going to come in upcoming months, so don't wait till it is over for you. So join our WhatsApp channel now to get all the latest update. Click on the notification icon in our WhatsApp channel so that whenever we are posting something new, you are getting that notification as early as we are posting it, right? So now my announcement is over. Now we can go to the lecture. So let's start with today's lecture. First question: on a new scale of temperature called R scale. Okay, R scale. Okay, it can be R scale, it can be any X scale. The freezing and boiling point of water are 30 degree R and 230 degree R respectively. What will be the temperature on the new scale corresponding to a temperature 30 degrees Celsius on the Celsius scale? Okay, so very interesting question. So how to solve this? We know that any scale, if you are using any random scale where you know the lower fixed point and upper fixed point, these are called lower fixed point and upper fixed point, right? So freezing point of water is lower fixed point and boiling point of water is upper fixed point. So if the temperature in that scale say X, okay, then X minus lower fixed point divided by upper fixed point minus lower fixed point equals to the scale with which you are comparing. In this case Celsius scale we are comparing, so 30 Celsius minus its lower scale, lower fixed point, divided by upper fixed point minus lower fixed point. Okay, for Celsius scale lower fixed point is 0. That is the main benefit. That's why we are using Celsius scale. It is very popular, right? Now let's solve this question. So this is the equation. So X minus 30 divided by 200 equals to 30 divided by 100. Now I have not done this calculations while taking the classes because I thought this is super easy. So and you have done this in your previous classes perhaps. If you have not done, then you have to listen to this carefully, the process that I am describing now, so that you can answer if such easy question comes in your KCET. So the answer is 90 degree R. Okay, so 90 degree R is the answer. Okay, now next question: a monoatomic gas is suddenly compressed to 1/8 of its initial volume adiabatically. So very important, the process is adiabatic. The ratio of its final pressure to initial pressure is, so ratio of its final pressure to initial pressure, very important. Okay, always I say whenever they ask you to find a ratio, you have to find A is to B or B is to A. Both are important, right? In the options they will definitely give you answer such that it is either A is to B or B is to A. So you have to be careful with what you are finding the ratio. Okay, which is first, which is second. In this case final pressure is first, initial pressure is last, right? So assume that final pressure is say P2, okay, initial pressure is P1, okay, final volume is V2, initial volume is V1. Okay, now it is given that the final volume is 1/8 of V1. So it is compressed to 1/8 of its initial volume. So V2 will be 1/8 of V1, right? So now we know that adiabatic process means P1 V1 to the power gamma is equal to P2 V2 to the power gamma. So be careful, because it's adiabatic process, okay, it will be PV to the power gamma is constant, okay? So be careful, okay? Gamma is written like this, right? So now what we have to do, we have to find P2 by P1. So what we will do, we will take this P1 and we will divide it in this side. So in this side we will have V1 by V2 to the power gamma is equal to P2 by P1. We are trying to find P2 by P1, right? So P2 by P1 equals to, what is V1 by V2? So if you see from here, we are trying to find, so cross multiplication, V1 divided by V2. So this one will go down, this one will come up. So V1 by V2 is 8, right? So V1 by V2 is 8 to the power gamma. What is gamma? Gamma is 5 by 3. Gamma value is given, monoatomic gas, right? So now how to do this value, this calculation? First, as I said, we will try to calculate 1 by 3. First we will take out the division part, whatever to the power division is there, that we will take care of. So 8 to the power 1/3 is 2 cube to the power 1/3. So now this 3 cancels, so it is 2. So to the power 1/3, 8 to the power 1/3 means 2. So basically cube root of 8, that is 2. Now what is left? Only 5 is left, okay? So 2 to the power 5 is what we have to calculate. Now 2 to the power 5 is 2 times 2 times 2 times 2 times 2. 5 times 2. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So the answer is 32. Okay, so correct answer is 32, not 64, not 40 by 3, not 24 by 5, not 8. Correct answer is 32. Okay, clear? Any doubt? Don't forget to mention that in the comment below. A steel ball of mass 0.1 kg falls freely from a height of 10 meter and bounces to a height of 4.5 meter from the ground. If the dissipated energy in this process is absorbed by the ball, okay, the rise in temperature is, all the required constants are given, the specific heat of steel is given, G is given, okay. Very interesting question. So what is the problem? First understand the problem. You are dropping a ball from a height of 10 meters, okay. After colliding the ground, it is going up to a height of 5.4 meter. Okay, so this is the height it is reaching after bouncing. So rest of the energy is getting absorbed by the ball itself. What is the rest of the energy? So initial potential energy of the ball is mg h1, capital H, say assume capital H, okay, capital H is equal to 10, okay, and the final potential energy after it reaches this height is mg small h. Okay, small h is 5.4. Okay, so what is the difference in the energy? There is a difference in energy. That difference in energy is called dissipated energy. That dissipated energy is absorbed by the ball itself. So how much energy is absorbed by the ball? Simple, mg capital H initial energy minus mg small h final energy. So it is mg h minus h. Okay, now we will put the values given in this question and calculate this energy. M is 0.1 kg, G is 10, H is 10, small h is 5.4. Okay, so 0.1 times 10 is 1 and 10 minus 5.4 is 4.6. So 4.6 joule energy is being absorbed by the ball. Okay, so if this much energy is absorbed by the ball, okay, and if its temperature increase is delta T, if the temperature increase is delta T, then from the conservation of energy we can again write ms delta T should be equals to this energy E. Okay, energy is not destroyed, energy is not transferred into any other form of energy. So basically whatever energy is dissipated, the same energy will be absorbed by the ball, and the temperature rise is given by ms delta theta, that is the energy, heat energy, right? So what is m? M is 0.1, S is given here 460 joules. 460 joules. Let's see delta T. We don't know delta T, and E is 4.6. Okay, so 0.1 and this 0 will cancel, right? 0.1 means 1 by 10, so we have cancelled 0.1 with this 0. So delta T is basically 4.6 divided by 46. Okay, that is 1 by 10. Okay, so 4.6 by 46 is 1 by 10, that is 0.1 degrees Celsius. Okay, so 0.1 degrees Celsius is the rise in temperature. So very small amount rise will happen, but in practical cases obviously the ball does not absorb the entire amount of energy. Some part it definitely absorbs, and if you throw a ball repeatedly, after some time the ball gets heated because it is absorbing that energy. That's why its temperature is increasing. Right, now let's move on to the next question. Very interesting basic question. A liquid oxygen at 50 Kelvin is heated to 300 Kelvin at constant pressure of 1 atmosphere. The rate of heating is constant. Which one of the following graph represented the variation of its temperature with time? Okay, boiling point of oxygen is 90 K at 1 atm. At 1 atmospheric pressure, the boiling point of oxygen is 90 Kelvin. Okay, obviously we know that for gases it depends on the temperature of pressure of the object, right? So in this case, as you know, when you have a liquid oxygen, okay, when you are increasing its temperature, it's increasing the heat. As you are supplying heat, its temperature will increase linearly. And then when it reaches the temperature of 90 Kelvin, okay, when it this is the heat energy. When it reaches the temperature of 90 Kelvin, okay, then at this point of time, whatever heat you will supply, that heat will be used by the oxygen to convert it into a gaseous form. So at this point of time, till the entire oxygen is converted into gas, its temperature will not increase. Its temperature will not increase, it will remain constant. So it will be a flat graph. Till entire oxygen is converted into gas, again the temperature will increase. So very basic old theory. Okay, if you remember this, you can answer this question. So this is the answer for this question. Okay, so the temperature versus time graph will be like this. As you are seeing, okay, more energy you will supply, but after some time its temperature will constant, because at this point this is the phase change state. Okay, at this point everything is liquid O2. At this point everything is gaseous form of O2. Okay, in between there is a mixture of states. Some liquid are still in liquid phase, some liquid are converted into gaseous phase. So temperature remains constant till this point. We know that it happens for boiling of water as well. It happens for melting of ice as well. When the entire ice, until the entire ice is melted, it remains the 0 degree Celsius, right? Similarly for oxygen, only thing is they have changed. Instead of asking the question in terms of ice or water, they have given you oxygen. But the same thing will happen. Now, water is heated from 0 degree to 10 degrees Celsius. Then its volume. So we know that as you are heating the water, okay, from 0 degree to 10 degree, its volume decreases up to some point, then again it starts increasing. There is a point where its volume is minimum. So this is 0 degree, suppose. Then when its volume is minimum, its volume is minimum at 4 degrees Celsius. Density is maximum. Density maximum means volume is minimum. Mass is constant, right? Mass of an object is constant. So mass cannot change. At this point, density becomes maximum, volume becomes minimum. After you crosses this point, again volume starts increases. So from 0 to 4, it decreases. From 0 to 4 it decreases, from 4 to 10 it will increase. So first decreases and then increases. So option B is correct. Generally these kind of answers are incorrect, but for water it is called anomalous expansion of water. For water this option is correct. Okay, in any other cases if they say okay first increases then decreases, generally that option is incorrect, but for water this is an exception. Okay, next question. 100 gram of ice at 0 degrees Celsius is mixed with 100 grams of water at 100 degrees Celsius. The final temperature of the mixture is. Very interesting question. So how to solve this question? So first, what is the mass of ice? What is 100 grams? That is 0.1 kg. Okay, what is the mass of water? Mass of water is also 100 grams. This is also 0.1 kg. Okay. Now for convenience, instead of using M1, M2, because both of them are same, particularly for this case, I will use only small m. Okay. Now for melting of ice, first stage. Now here we have a beaker where we have boiling water, hot water 100 degrees Celsius, and then we have added the ice. So when they are mixing, the final temperature of this case may assume this is capital T, okay, so, or small t, okay, because we are using Celsius scale, let me use small t. Okay, so the final temperature of this system is assume small t. So when entire ice will melt, then everything is water, everything's temperature will change, right? So first stage is melting of ice. So during the melting, how much heat is absorbed by the ice? The heat absorbed by the ice, say H1, is basically mLF, right? F is the heat required for melting, right? Latent heat of melting or latent heat of freezing. In this case, because they are using F, so latent heat of freezing. Now what is the mass? Mass is 0.1. What is latent heat of freezing? 3 point. This is a little long for calculations, but problem is very simple. Step by step, if you solve, you can answer this question. So 0.1 times 10 to the power of 5. So we can simply reduce 10 to the power of 5 to 10 to the power of 4. Right? 0.1 means 1 by 10 or 10 to the power of minus 1. So we just need to reduce it, and this is the first stage heat required. Okay, this is the first stage heat required. Now what is the next stage? Next stage is the ice after melting, it will have a water of 0 degrees Celsius, right? So ice will become water of 0 degrees Celsius. So this is the old water, this is the new water from melting of ice. Okay, so this water will now reach from 0 degree to T degree Celsius. Right, this is the second stage, and this water will reach from 100 degree, its temperature will decrease to T degree Celsius. So everything will reach the final temperature of T degrees. Okay, so the second stage, the heat that is absorbed by this water is given by MST. This is the second stage heat. This is the second stage heat for ice. Okay, so now M is 0.1, S is 4.2 times 10 to the power of 3, right? Yes. And T we don't know, so it will become 4.2 times 10 to the power of 2T. So 0.1, 10 to the power of 3, 1 cancels, right? 4.2 times 10 square T. Now this is the entire heat that is being absorbed. How much heat is released? So the heat released by the hot water is Ms 100 minus T. This much heat is released by the water when it is at 100 degrees Celsius. So what is that? 0.1 times 4.2 times 10 to the power of 3 times 100 minus T. Okay, or let me calculate this. 4.2 times 10 to the power of 2 100 minus T, or 4.2 times 10 to the power of 2 times 100 minus 4.2 times 10 square T. Okay, or this will become 4.2 times 10 to the power 4 minus 4.2 times 10 square T. So this is the heat that is supplied, right? This amount of heat is supplied, this amount of heat, this heat and this heat is absorbed. So H is basically H1 plus H2, right? This is the basic mathematics. Energy cannot be created or destroyed. So whatever heat you supplied, that same amount of heat should be absorbed. So we can say that 4.2 times 10 to the power of 4 minus 4.2 times 10 square T equals to 3.36 times 10 to the power of 4 plus 4.2 times 10 square T. Both of them are same. So now let's take this on other side. So it will become 4.2 minus 3.6 whole 10 to the power of 4. Both of them has 10 to the power of 4. So this will be common because it was on that side, so it will come and become negative. And let's take this on the other side. This on the other side means it will be plus. Now 4.2 plus 4.2, it will become 8.4 10 square T. Right? So what is T now? Final temperature. Okay, I need this space. Unfortunately, I have to remove this. Okay. Okay. Now let's start. So T is basically equals to 8.4 times 10 to the power of 2 divided by, now 4.2 minus 3.6. 4.2 minus 3.6, it will be 0.8. Right? Sorry, I think I made small mistake. It is 3.36. 3.36. So basically 4.2 minus 3.6 is 0.84. You can check that. Okay, they have given you the value such that you will get the same value in the but with a decimal. So it is 10 to the power 4. Okay, so now you can cancel 10 square with 10 to the power 2 here, or 8.4 divided by, if you multiply it, it will be 84. That is 1 by 10, that is 0.1. Okay, so where I made a mistake. So here as you can see that 8.4 times 10 square T is equal to 0.84 10 to the power of 4. So this will be 0.84 10 to the power of 4, right? Because 4.2 minus 3.6 is 0.84 times 10 to the power of 4, and this was our T side, so it will come and divide it on the other side. So here you have to divide it by 8.4 times 10 to the power of 2. Okay, so this will cancel. It will be 10 square, or it will be 84 divided by 8.4, or 10 degrees Celsius. So 10 degrees Celsius is the answer for this question. Little long, but some questions do come lengthy. Okay, so you cannot avoid that. You have to attempt all such questions. Okay, maybe guess it properly, maybe understand it, or try to solve it whatever way you are comfortable with. So this is the way to solve this methodically. Okay, now next question, question number 7. A sphere, a cube and a thin circular plate, all the same material, same mass, initially heated to the high temperature, are allowed to cool down under similar condition. Then which one will cool faster? Okay, the plate will cool fastest and the sphere will cool the slowest. Okay, plate has the more surface area means faster cooling, and less surface area means slower cooling for perfect objects. Sphere has the smallest area, right? So sphere will cool down slowly as compared to plate, and cube will be in between somewhere. Okay, now next question, this is a diagram based question. The thermodynamic system undergoes a cyclic process ABC as shown in the diagram. The work done by the system per cycle. So work done, as I said, work done in such cases is basically the area under the graph. So basically you have to find the area of this triangle. Okay, simple question. Many of you are familiar with this question. So what is the area under the graph? Work done is basically half height. Height is 400 minus 100, that is 300. Okay, what is base? Base is 10 minus 5, that is 5. Okay, this is the work done. Now it is going in this direction, so it is a positive work done, right? So it will be 5 15 the 75, 750 joules. So correct answer is 750 joules. So in this direction the work done is positive, in this direction work done is negative. Okay, next question. The SI unit of specific heat capacity is, the SI unit of specific heat capacity is joule per kg per Kelvin. That is the SI unit. The efficiency of a Carnot engine which operates between the two temperatures T1 is equal to 500 Kelvin and T2 is equal to 300 Kelvin. So efficiency is 1 minus T2 by T1. So 1 minus 300 by 500. Okay, in case you confuse, it will be always smaller value divided by the bigger value. So 2 zeros cancels. So it will be 1 minus 3 by 5 equals to 2 by 5. Now you have to find it in percentage. So eta percentage is equal to 2 by 5 times 100%. 5 20 is 100, so 40%. So the efficiency is 40%. Next question. A cycle tire bursts suddenly. What is the type of this process? This is adiabatic process. Any sudden process is an adiabatic process. A monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V and then adiabatically to a volume 16V. The final pressure of the gas is, so first we have a gas, it goes from volume V to 2V, okay, in isothermal process. Then 2V to 16V in adiabatic process. Okay, suppose the initial pressure is given P. Okay, suppose the pressure in this stage is P1 and in this stage is P2. Okay, so now from first stage, from this stage, okay, PV is equal to P1 2V. Okay, or P1 equals to P by 2. Right? Understand? V will cancel and this 2 will come down here to P by 2. Now next we have to apply adiabatic law for this step. Okay, this step. We have to apply adiabatic law for this. This is adiabatic. Okay, now let us apply adiabatic law. P1 2V is equal to 16V P2 or P2 16V. Okay, let's not break the order. P2 16V. Okay, now what is P1? P1 is P by 2 times 2V is equal to P2 times 16V. P2 cancels. Okay, so V cancels. So P2 is equals to, sorry, my mistake. I made a silly mistake here. This is an adiabatic process, right? So in adiabatic process, it will be gamma. Yes. So don't make mistake like me. So P1 is P by 2 equals to P2 16V divided by 2V to the power gamma. So P1 we have kept as it is. P1 is P by 2, so I have kept that as it is. Only thing we have take this value on the other side and divided it. Okay, so V cancels, 2 cancels, 8. So P2 times 8 to the power gamma. So what is gamma here? Gamma is monoatomic, again 5 by 3. We have already solved one such question for 8 to the power 5 by 3. So it will be P2 to the power 5, that is P times 32. So P2. So P2 will be P by 2 times 1 by 32, that is P by 64, right? So P by 64 is the answer. Okay, if you have answered 64P or 32P or 16P, you made a mistake, because, and also you can guess, actually you can guess this answer. Volume increasing means pressure will definitely decrease. Okay, and now in both cases, first step also volume increases, in the second step also volume increases. So only one possible answer is P by 64, because in this case only pressure is decreasing. All the other options they have given, pressure is increasing. Okay, in case they give you an option that P by 32, in that case you have to solve this. Otherwise, without only solving, just looking into the options, you can see, hey, this is directly P by 64. I don't have to solve it. Next question. The ratio of molar specific heats of oxygen is 1.4. Okay, this is a diatomic gas. For diatomic gas, gamma is 1.4. That is the ratio of specific heat, right? A certain amount of heat energy is supplied to a monoatomic ideal gas which expands at constant pressure. What fraction of the heat energy is converted into work? Now, while doing my regular class, I think we came across this question and I said this is out of syllabus. Actually, this is not out of syllabus. This question is part of the syllabus. I am sorry for that. So, I am going to compensate and I am going to solve this question now. So, what is this question is about? From first law of thermodynamics, we know that heat supplied is basically part converted into internal energy and rest is into work. Okay, so this is the first law of energy, first law of thermodynamics. If you give Q amount of heat, then some part is converted into internal energy, some part is converted into work. Right now, from the definition of heat and Cp and Cv, okay, we know that this is nothing but Cp delta T. Okay, if you remember, we have learned about the definition of Cp. Okay, it is 1 by N dq by dt at constant pressure. Right now, in case of constant temperature, in case of constant volume, work done is 0. So in that case, when you put constant volume, in this case Cv, that actually becomes 1 by N du by dt. This capital T, obviously. Okay, so this is the case. This is when you do the when the volume is constant, work done is 0. So basically that's how you get the relation. This is nothing but Cv delta T or dt. Dt delta T is same. So this is the work done. So this all related to the definition of Cp and Cv. Okay, now what is work done in this case? So work done in this case is N Cp minus Cv delta T, right? So just take this on the other side, take whatever common you can take, and that will give you the work done. Now they have asked you what fraction of the heat. So what fraction of the heat means? Fraction of the heat means W by Q. So W by Q is the fraction of heat that is converted into work, right? So Cp minus Cv delta T divided by N Cp delta T. So this is Q, Q is this, right? So Q is nothing but N Cp delta T, right? So that's what the definition tells us. So N cancels, delta T cancels. Now do the division. Cp by Cp is 1 minus Cv by Cp. Now what is this Cv by Cp? We know that Cp by Cv is the ratio of specific specific heats, that is gamma. So Cv by Cp will be 1 minus 1 by gamma. Okay, now here it is mentioned that a monoatomic gas. Monoatomic gas means gamma is, for a monoatomic gas, the gamma is 5 by 3. So 1 by gamma will be 3 by 5. Okay, for monoatomic gas, gamma is 5 by 3. Right? So here you will get 2 by 5. So 2 by 5 is the answer. Okay, no matter what, you cannot convert 100% energy into work. Okay, so that you have to be careful. Okay, 100% energy cannot be converted into work. So obviously 1 is not an answer. If you having difficulty, you have to solve it. If you want to guess, don't guess 1. Right? Now, next. Pressure of an ideal gas is increased by keeping temperature constant, the kinetic energy of the molecules. Now, if the temperature of the gas is constant, kinetic energy does not change, energy does not change, energy is per degrees of freedom half kBT. If temperature is constant, this energy will remain constant, so it will not change, it will remain the same. Okay, next question. The mean energy of a molecule of an ideal gas is 3 by 2 kBT. We already discussed that during our lecture, so I just answer it. Next question, the time taken by, from now question number 17 to question number 30, all the questions are based on AC. So for thermal physics, 16 questions are done. Now let's move on to next 14 questions from AC. The time taken by AC of 50 Hz in reaching from 0 to the maximum value. So the time taken by AC to reach from 0 to maximum is 1 by frequency. Okay, that is 1 by 50 seconds. So that is 2 by 100 seconds, that is 2 times 10 to the power of minus 2 seconds. So this is the answer for this question. Okay, you have to remember that time taken by an AC to reach the maximum value is basically 1 by F, which whatever you have to calculate. Now next question, the value of the alternating voltage V in the given circuit will be. So what is the alternating value of V? We know that V is equals to square root of VR square plus VL minus VC whole square. It does not matter. Okay, we know that VL and VC, there is a square sign here, so it is VL minus VC or VC minus VL, both are same. Only the thing is the meaning is different. If VL is greater, then it is a inductive circuit. If VC is greater, it is a capacitive circuit. Otherwise the formula does not matter, the formula is same. So in this case, what is VR? VR is 80 volts, so 80 square plus VL minus VC is 100 minus 40 whole square. So this is 80 square is 6400, 100 minus 40 is 60 square is 36 0, 0. So if you add them, you will get V equals to square root of 10100. So it will be 100 volt. Okay, so 100 volt is the answer. Do not blindly just add them up or subtract them up. Okay, so be careful, you have to be careful to answer this question. Okay, next, in a series resonant, very important, resonant RLC circuit, the voltage across R is 100 volt and the value of R is 1000. Okay, the capacitance of the capacitor is 2 times 10 to the power of minus 6 farad. Okay, angular frequency of the AC is 200 radian per second, that is omega is 200 radian per second. Then the magnitude of potential difference across the inductance coil. The question might seem difficult, actually it is a very simple question. So what you have to do first, voltage across R is given and resistance is given, so you can find the current in the circuit. Current in the circuit, the maximum current in the circuit obviously is V by R, right? VR by R, we already know that. Take any component in a series circuit and if you divide the potential across that component divided by its value, its resistance, you get the current, right? So what is VR? VR is 100 volts and resistance is 1000. So basically it's 100 milliampere. Okay, divided by 1000 means milli, right? So milliampere. Okay, so current in the circuit is 100 milliampere. Now we are trying to find, or you can say, okay, let's not go to milli, let me write in volts only, 0.1 ampere. Okay, 0.1 ampere, that is also fine. Now what we are trying to find, we are trying to find voltage difference across the inductor. Now in case of resonance, voltage across inductor is equals to voltage across capacitor. This is the very important point to remember. Okay, now because it's resonance, obviously VL equals to VC, so if we can calculate VC, we will be also be able to calculate VL. Now how to calculate VC? VC is what? VC is XCI, right? XC is the impedance of the capacitor or capacitance of the circuit. Now capacitance, what is the formula for capacitance? Capacitance is 1 by omega C. Right? What is omega here? Omega is given 200 radian per second. C is given 2 times 10 to the power of minus 6. Excuse me. So it will be 1 by 4 times 10 to the power of minus 4. These two zeros are adjusted here, or it will be 10 to the power of 4 divided by 4. So 10 to the power of 4, we can write it 100 times 100 divided by 4. So it will be 25. So 2500. Okay, so 2500. So this is a way, how much, whatever way, if you can solve this, that is fine. This is ohm. Okay, capacitance is obviously in ohm. Okay, capacitive reactance. So basically now we have to calculate this. So VC equals to 2500 times the current 0.1 ampere, that is 250 volt. So 250 volts is the answer for this question. More such questions you practice, better you will be. It is a very easy question, it is a solvable question, but to solve these questions you have to practice and only practice. Next question, AC supply is represented by V equals to 141.4 sin 100 t is applied. So there is a reason that I am stumbling upon this value, because it is very common to one of the known value. If you know what is the known value, mention that in the comment below. Okay, even though that this value is not exactly matching, but we will see that how it is relevant. Okay, applied to a series LCR circuit, impedance of 50 ohm. Impedance of the circuit is 50 ohm. Where the resistance has a value 40 ohm, the circuit behaving capacitive, the RMS current in the circuit is. So now first of all, since impedance and voltage is given, we do not need anything else. Okay, impedance is 50 ohm. Okay, voltage is, we know that this is given by Vm sine omega t. Whether the circuit is capacitive, circuit is resistive, so whatever value of the resistance, we do not need anything other than this. So we know that they have asked you to find the RMS value of the current. So we know that Im is basically Vm by Z and IRMS is Im by root 2. So basically you can say this is Vm by Z root 2 Z. Okay, so this is the value of IRMS. Now let's put the value of Vm. What is Vm? Vm is 141.4. What is root 2? Root 2 is 1.414, right? So that's what I was saying, that this value is very similar to root 2 because eventually it will cancel, and Z is given 50. Okay, so this will cancel and you will get 100. So you will get 2 ampere is the answer. Okay, 2 ampere is the RMS current. Okay, you don't need to worry too much. They have tried, the question is so simple that they have given you so much extra information not required to confuse you. So don't get confused, just use the method, just use the science behind it and answer it. Okay, a capacitor of capacitance 10 microfarad is connected to an AC source and an AC ammeter. Okay, if the source voltage varies as V is equal to 50 root 2 sine 100t, the reading of the ammeter is. So the capacitance is 100 microfarad, omega is 100, so capacitive reactance is given by 1 by omega c. Omega is 100 in this case. This is omega, this is C. 10 microfarad means 10 times 10 to the power of minus 6. Okay, so if you multiply it, it will be 1000 times 10 to the power of minus 6, or 1 by 10 to the power of minus 3, or 10 to the power of 3, or equals to 1000. Okay, so Xc is basically equals to 1000 ohm. Okay, so you have calculated the value of Xc. Now only thing that is left is to calculate the reading of the ammeter. Now reading of the ammeter will read RMS current. Okay, now there is nothing else in this case, so Xc, Z will always be Xc in this case because no resistor is included, only capacitor is included, so Z will be equals to Xc in this case. So what is the current? Current will be Vm by Xc. So let me calculate the current first in this case for a change. So Vm is 50 root 2 by 1000. Now if you see, all the answers are given in milliampere, so we will say this is 50 root 2 milliampere. This is the maximum current. Now what will be the RMS current? Ammeters will always read RMS value, that is Im by root 2, that is 50 root 2 divided by root 2, it will cancel, so it will be 50 milliampere. Okay, so 50 milliampere will be the answer. Okay, I hope you are understanding these questions, right? If you have not, okay, you have to revise the chapter AC once more. Next, the following circuit VC equals to 40 volts, then VR and the current are approximately. So in this case, what they have given two parts. Okay, one is resistor of 60 ohm and some capacitance C. Okay, and the voltage 50 volt, thus frequency 50 hertz. Okay, so in this circuit they have said VC is 40 volts. So here the VC is 40 volts. Now what to do? What do we need to calculate the capacitance, etc., then find R? Are we so fool? Obviously not. We will use simple formula that V equals to square root of VR square plus VC square. Rest everything whatever they have given is not required at all. So as I said, there will be a lot of cases when they will try to fool you, but we will use simple mathematics of as much as possible. So V is given 50 volts, so only thing that we need to require is 50 volts. So 50 square equals to VR we are trying to find, and VC is given 40 volts, so 40 square. So VR square equals to 2500 minus 1600. So this is 1600, this is 2500, so this will go on the other side, become negative, so it will be 900. Okay, so VR will be square root of 900, that is 30 volt. 30 volt. Okay, now what will be the current? So we know VR, we know R, so current will be VR by R, as simple as that. So 30 volt divided by 60, that is 0.5 volts. Okay, sorry, 0.5 amperes. Okay, so here answer will be 30 volts, 0.5 amperes. Okay, now next question. An ideal transformer has a turn ratio of 10. When the primary is connected to 220 volt 50 Hz AC source, the power output is. So as we know, in an ideal transformer, power input and power output are same. It does not change. So here it is equals to the power input. Very, very careful. Okay, in an ideal transformer, power input equals to power output. Now next question. In an LCR circuit at resonance, the current is minimum. No, wrong, current is maximum. So this is definitely wrong. The current and voltage are in phase. Yes, this is correct. Current and voltage are in phase. So this is the correct answer. Let's check the other options. Current leads the voltage by pi by 2. No, that is wrong. They are in phase. The impedance is maximum, so impedance is not maximum, in fact impedance is minimum, so this is also wrong. Okay, in case of resonance, XL and XC, they cancel each other, only resistance remains, so circuit is purely resistive, that's why current and voltage are in phase. Okay, that is the reason behind this. The average power dissipated in a pure inductor is, in a pure inductor, average power dissipated is 0. In an ideal transformer, the voltage and the current in the primary is 200 volt, 2 ampere, and that in the secondary are 2000 volt and I ampere. The value of I is. So we know that what is power dissipated? Power dissipated is V I. So V1 Vp Ip equals to Vs Is. That is the voltage of the primary times current of the primary is equal to voltage of the secondary times current of the secondary. So here Vp is 200, current is 2 ampere, Vs is 2000, and I we don't know. So let's find whatever the value of I, 0, 0 cancels. So it will be I equals to 4 divided by 20. Okay, so it will be 1 by 5. 1 by 5, that is 2 by 10, that is 0.2 ampere. So the answer is 0.2 ampere. So as you see, the voltage increased but the current decreases, right? So this is the beauty of the transformer. Next question, a step down transformer. Another question on transformer. A step down transformer reduces the voltage of a transmission line from 2500 volt to 220 volts. The power output is 880 watt and its efficiency is 88%. The input current is. So very interesting question. First, what is the power of the primary? Power of the primary is Vp Ip. Okay. And what is power output? Power output is 88% of the power primary. Everything else we do not need. Okay, 88%, that is power primary times 88 divided by 100. Okay, now this, there is a mistake in this question, I think. This will be 2200. Okay, 2200 volt. I hope your version is correct. Somehow my version is incorrect. So what is power output? Power output is primary times current in the primary. So 220 volt, 100 volt times IP is, we are trying to find, times times 88 by 100 equals to 880. So this will be 8 11 88. So let's check this question. A step-down transformer reduces the voltage of a transmission line from 2500 to 220 volt. The power output is 880 watt and its efficiency is 88%. The input current is very interesting, 88, 88, 880. So what is the power input? Power input is voltage input times current input, that is voltage in the primary times current in the primary, right? Now what will be the output, power output? Power output is power input times the efficiency, that is 88% in this case, that is 88 by 100. Now power output is given 880 watts. Power input is VP IP. What is VP? VP is 2500. IP we don't know, we are trying to find it out. So 2500 times IP equals to 88 by 100. So 88 times 880 is 100. Okay, right? Yes, no, sorry, it will be 10 times 88 is 880. So 2500 times IP equals to 10 times 100, that is 1000. Okay, so IP will be equals to 1000 divided by 2500. 0 0 cancels. Okay, so it will be 10 by 25. Now let me multiply top and bottom with 4, so it will be 40 divided by 100. 525 is 100, so one of the zeros cancels, it will be 0.4 ampere. Okay, 0.4 ampere is the answer. Next question, 28. An alternating voltage of frequency 50 Hz is fed into a circuit having resistance of 628 ohm and inductance of 2 Henry. Phase angle between the current and the voltage is. So to find the phase angle, we have to calculate tan phi. What is tan phi? Tan phi is XL by R. Okay, in this case XL minus XC is in general, but XC is not there, so we just need to find XL by R. Okay, so what is XL in this case? So L is inductance, is inductive reactance. L is 2 Henry and 2 pi FL. Okay, omega is 2 pi F. So 2 pi F is 50 Hertz, L is 2. So it will be 2 times 3.14 times 100. Right, 50 times 2 is 100, or 2 times 3.14 is 6.28 times 100. So XL is 628 ohm. So tan phi is 628 divided by 628. Resistance is also given 628, right? So it is 1. So phi is 45 degrees. So the phase angle is 45 degrees. Okay, next question. A resistor and a capacitor are connected in series with an AC source. If the potential drop across the capacitor is 5 volt and that across a resistor is 12 volt, the applied voltage is very simple. V is equal to VR square plus VC square. So VR is 12 volt, 12 square plus 5 square. So square root of 144 plus 25, that is square root of 169, that is 13 volt. So the applied voltage is 13 volt. Last question. When 100 volt DC is applied across a coil, a current of 1 ampere flows through it. When 100 volt 50 Hz AC is applied to the coil, only 0.5 ampere flows. The inductance of the coil is. So this is a little long question. So how to solve this? First step is to calculate. So basically in the coil there will be a resistance and there will be an inductance. Okay, and you have first you applied a DC. In case of DC, inductance does not give anything, only the resistance will provide resistance. So in this case, okay, the current in the circuit is given by I is equal to V by R. So from there you can calculate R is equal to V by I. So first stage is to calculate the resistance. What is the resistance? So first stage, when you apply 100 volt DC, current is 1 ampere. So 100 volt DC by 1 ampere, so 100 ohm is the resistance of the circuit. So 100 ohm is the resistance of the circuit. Now in the second stage, okay, when you are connecting the battery with the AC source, okay, the XL will also act. So in this case, what is the reactance? Reactance you have to calculate, okay? Inductive reactance. Inductive reactance XL is omega L or 2 pi F L. Okay, since the option answer has pi, we will not put the value of pi in this case. We will put the value of 2 pi. F is 50 times L, so 100 pi L. Okay, so 100 pi L is XL. Now what is Z? Inductance of the circuit. Inductance of the circuit is square root of R square plus XL square. Okay, we will not use it immediately. We will wait for one more stage. What is that? Oh, okay, let me do this right now. No, we will do it after one more step. Okay, now they have said that after this is connected to this AC, the current in the coil is 0.5 ampere. So what is the current now? The new current is V divided by Z. So Z is equals to V by I. Okay, so what is V in this case? V is same. So Z equals to V is 100 and I is 0.5. So it will be 200. Right, it will be 200. Now let us square both sides. That will be easier for us. So square will be 400 and double. So this is the value. Now Z square is basically R square. R square is 100 square. Okay, plus XL square equals to 40000. Right, now. So XL square is equals to 40000 minus 10000. So it will be 30000. Okay. So what is the value of XL? So XL is basically root 3 times 100. Okay. So XL is root 3 times 100. Now put the value of XL. XL is 100 pi L equals to root 3 times 100. 100 cancels. So L is equal to root 3 by pi. Okay, so L is root 3 by pi. So this is the correct answer. Okay, I hope you enjoyed this session. I were at the end of this lecture, so tomorrow I will bring you another last class of the KCET section. Okay, so all the chapters are already completed. Tomorrow we are discussing I think tomorrow will be last chapter, waves chapter. Oscillation is already completed. So till after we finish the lecture course, then we will decide what to do next. Till then you can revise all the chapters. The KPL session will continue but regular chapter wise classes will not be happen every day. We will do some revision soon, but that will take some time. Till then I will be back with lecture tomorrow, and don't forget to like, share and subscribe. Bye.